This is BaslerCast, tutorials for Mr. Basler's physics class. This video's topic is average and instantaneous velocity. Let's take a look at how we determine velocity from a position versus time graph. Here's a graph, but in this case there's no straight lines, there's a curve. If we choose 2 points and draw a line, we can then find the slope of that line, and that slope will give us the average velocity. If we want the average velocity for a smaller interval, we just choose 2 points that are closer together. Even smaller, the smallest selection is the slope of the tangent to the curve at the point on the curve. That point represents the position of the object at an instant in time. The slope of the tangent at that point is the velocity of an object at that instant. An instant of time is referred to as 1 clock reading, and the slope of the tangent line at 1 clock reading is known as instantaneous velocity. The slope of a tangent line, or the instantaneous velocity, changes from 1 clock reading to another. We can determine instantaneous velocities at several different clock readings, and then use those velocities to plot a velocity versus time graph for the object's motion. Let's compare a couple graphs. Here we have a graph that has a velocity that is constant, it's fixed at some high positive velocity. The position versus time graph is going to look like a constant positive slope. However, we don't know where the origin is. One thing a velocity versus time graph cannot do is it can't convey the initial position. So the red line could actually be anywhere on the y-axis. A velocity versus time graph can, however, convey change in position or displacement, or delta x. We can find the change in position by taking the velocity times the time. If you look at the units from that, you're going to have meters equals meters per second times seconds. Seconds cancel out, and you're left with meters, which is the displacement in this case. Here's another graph. Now this particular graph, we look at how we can get a position versus time graph out of this. Again, we don't have any information about where it starts, so I'm getting rid of the origin because it could be anywhere on the y-axis. If we look at the first the first instant, we have a thing starting off at 0 velocity. So 0 velocity on position versus time graph means a slope that is flat, a 0 slope. The next spot is a velocity somewhere in the middle, so we have a red slope somewhere in the middle. And the final velocity is our highest slope, so we get our steepest slope over here with the red line. Fill in the blanks, and now we have a slope. Now we have the position versus time graph for this velocity versus time graph. Now this can start anywhere along the y-axis because, again, it doesn't convey the velocity versus time graph, that is, doesn't convey anything about initial position. Only tells you what your velocity is.
That's it for this BaslerCast tutorial. You can find more tutorials over at the website. But for now, thanks again for watching.